Okay, so this is going to be a short video or short segment where we are trying to analyze the issue with the bias oscillator of this cassette deck. This is Hitachi D-E7. Issue is when we are recording, the voltage here on the race head is dropping all the time. Frequency is correct, but voltage is dropping. Also, I've noticed that this transistor is getting hot. After like few minutes, it's already pretty hot to touch. So clearly we have an issue, and because the bias current is dropping, so like with time, so someone is sinking quite a lot of current. And we need to find how and where. Okay, so this is the area of the bias oscillators. Looks like bias oscillator here is not shielded like in other cassette decks, but whatever. This is even better because we can work easily with this particular circuit, because in some other cassette decks the bias oscillator is completely like a complete unit. I can show you some videos I have captured for that. Alright, first of all, let me do some measurements and I'll show you how it looks like. So we're gonna power it up. We're gonna... Okay, this is just type 1 cassette, but I'm actually recording at metal. Doesn't really matter. So it is doing the recording. So we take our multimeter, plop it here, RMS, and I'll show you what is going on. This is true RMS multimeter. So across So this is the voltage across the record head, and as you see, it is dropping quite fast. You see that? In a few minutes, it's gonna be like 15 volts, and this transistor is heating up substantially. It's already pretty warm. All right, so it is clearly dropping some current voltage. All right, so here's something else I found in this. So there is a 16 volt rail here, and it's showing, look at this, 15 volt. Okay, so it's sinking, the voltage is dropping, but if you stop recording, it's actually going back to 16 volts. It's recovering. Okay, so clearly there is something wrong with the circuit. So let me analyze the circuit, and we can think about what how we can diagnose the issue. So we have our recording mode engaged. Let me find the ground plane. Here is the, not ground plane, grounding point. Here is a nice ground spot. Okay, let me check if you have 16 volt. We have 15.5. All right. Okay, so base. So emitter of this gentleman Q508 supposed to have, oh, it has 11.8 volt instead of 10.7. That's quite weird. Okay, collector supposed to have, it's in the center. Okay, that's correct. And the base 12.4. Yeah, look what the hell is going on here. It's bit off. Okay, let's check this guy. This guy is, oh, it's very hard to see. Anyways, this is the part of the oscillator, Q511, this guy. Okay, let's check. So its emitter supposed to have 0.85 volts DC. 0, that's not too far off. That's not too bad. And its base supposed to be driven 1 volt, 129. Like everything is freaking off. Okay. And the collector, which is connected only to the inductor, for some reason it's okay. It's instead of 10.6, oops, has 11.6. Okay. Oh, right. So that's not conclusive. Let me check something else. Let me see the frequency. I'm gonna be measuring right here. So I'll be measuring right here. So this capacitor and resistor, actually 85 kilohertz. So this thing generates 85 kilohertz. So I'm measuring right here. Okay, that's all good. Okay, so let me see the voltage drop across this weird orange capacitor, which is right here. Alrighty, so this is our board up close, and this is the back side of it. Okay, so here's our electrolytic C524. So this is the guy over here, and 525 is this guy. Okay, we obviously electrolytic, we can check the ESR, no problem, that's very easy. Here's my ESR meter in circuit. So I think we have no problem with that capacitor. Yeah, so at least ESR wise, it's good. The capacitance may be like off, but judging by the ESR, it's maybe good. So obviously we cannot measure the ESR or of this film mylar capacitor, so we have to unsolder it. Okay, to deal with this issue, I brought my desoldering gun. Okay, let me... Perfect. That's as easy as this. Okay, let's just pull this little tiny capacitor straight out of here. Let me find it first. Come, baby, come. Here it is. This is 5600 picofarad little tiny capacitor. Okay, let me measure it first. Maybe it's okay, maybe it's alright. Okay, I have this guy to measure the capacitor. Okay, capacitor is alright. 6000 picofarad. Then I do not know what to think. Okay guys, I have decided to actually replace this capacitor with 6800 nanofarad, 6.8 nanofarad capacitor, or 6800 picofarad capacitor. So here it is. It's 1 kilovolt, but whatever. It's film capacitor, but obviously not mylar. Sorry, not, yeah, this is mylar capacitor. I'm gonna keep it for now because I don't really think what else could be a problem here, except maybe there is an issue with the race head, which we have to disconnect and buzz and maybe measure inductance of the race head to see if it's too crazy or if there's something wrong with it. So it is upside down, so we still can power it up, I believe. Okay, and we'll try to measure voltage drop. Let me move it a little bit up. Okay. It's recording. Let's measure some. So this is our erase head right here. It's still dropping. Yep. Okay, this is across the capacitor, and this is 28 volt and dropping. Alright, I have also decided to desolder this capacitor, but looks like it is actually alright, so absolutely no problem with this capacitor. So this is C524. It's testing, and it says 94 microfarad, ISR is 1.8 ohm. So yeah, this 100. Oh, you don't see that. Jeez, it's barely seen. How do you? Yeah. Anyway, so the capacitor is good, so you have to put it back on. So the capacitor should go back on. Then I'm thinking, how about I test the inductance of the race head? Okay, so I'm gonna prepare these leads, and here is the race head. I'm gonna yank it, pull it out. Okay, this will show if there is a problem with the raise head. Oh my god, so dim. Okay, so it says, so you don't see that. Oh my god, 2.4 ohm inductance equal 0.36 millihenry. It's 360 microhenry, and at 900 kilohertz, whatever that means, Q factor is 6.2. Whatever. That these parameters. These parameters actually indicate that the raise head is actually a raise head. It's not shorted or anything. So raise head is, I assume, is okay. Okay, I've also decided to pull this 8530 resistor out. It is 5.6 ohm resistor. That's a very specific resistor, which actually, I think it's current regulation, because it's goes from here, from emitter down to the ground. 5.6 ohm. Let me see what's going on with this guy. Hope it's not shorted. .8 ohm. It's perfectly fine. Alright, next. I don't know what else we can double check, because everything seems to be alright here. Well, when I decided also to check the inductance of the record head. Okay, because it's all part of the same circuit. It's connected to the... Oh, it's not. Well, just double check it, never mind. Okay, it's 21 millihenry. It's much bigger inductance. Okay, let's check the other channel. Okay, like that. 25 millihenry, 22 millihenry, 79 ohm. Interesting. I don't have any other erase heads, just for giggles to double check. If the record head has like 79 ohm resistance, 21 millihenry, maybe there is an issue with the actual erase head. Okay guys, so what I've done, I've checked the erase head. It shows inductance but very low. It's like 360 microhenries. Some sources say it's alright. So check this resistor. This resistor is actually connected to the ground from the emitter, 5.6 ohm. It's not shorted, it's fine. I think it's setting the current right here in this base current in this circuit. This capacitor is put back, it is fine. This orange cap is put back, as it is fine as well. And that's all I can really check. Whatever is left is to try to check this capacitor, this transistor, because rest of the stuff is completely fine and it's pretty simple. So I'm gonna pull it out and double check this trainee to see if it's alright. Otherwise I'll have to seek an issue, yeah, somewhere else. I don't know what else could be, because this oscillator is this. This is not oscillator, this is just a voltage control as it says here. So I also checked the erase head. The erase head is 22 millihenries, much more inductance than this. Okay, our transistor is out, but for some reason it tests as a diode. Let me see. I might not put it properly in here. Just need to remember what's the right pin out. Okay, BGT NPN HEF 151. Yeah, it is a transistor. Yeah, it's actually completely fine. Yeah, it's how should we read? I'm gonna take a photo of this. Yeah, it's a lot of information right here. Pin 1, 2, 3, emitter collector base. Yeah, it reads. It's fine. So after continuous investigation, I couldn't really figure out what is the issue with this bias oscillator. So I decided to find a proper replacement transistor. So to actually find the proper replacement transistor was not easy, because this particular dude is not manufactured anymore. This is, where's the schematic? So this 2SD667AC is not manufactured anymore, okay? So the closest I can get, here is its specs, by the way. So here are the specs. Closest I can get is this KSC 2383. So it has kind of similar current characteristics. This is NPN. It has a similar HFE. It's pretty close in the ballpark, and it has a little bit better power dissipation. This guy can handle 1.2 watt. I think this guy can handle 0.9 watt. So, and it's the pinout is the same. So collector, emitter, and base. So you're gonna just be direct replacement. Hope I'm not gonna blow up anything in this bias oscillator, but today we're gonna replace this guy. I will probably unsolder it on camera, off camera. Alright, so here our old transistor is out, a new transistor is in. Let's see, power this guy up. And it is dropping as well, so it has nothing to do with the transistor. Unless it's supposed to kind of establish itself at some point, but it is dropping like no tomorrow, and I'm not sure what the fuck is going on. The frequency is 79 Hertz. This is not this. Ah, it's getting hot. It's getting hot as well. I'm not really freaking understand what's happening here. Okay, so after thinking about a little bit and testing everything in this area, and seems like everything is fine, I decided to go a little bit different way where we are. So here. So this voltage divider right here is actually, because voltage right here is wrong. So over here is supposed to be 1.1 volt when we are at metal recording mode, and it is 0.4. I mean, I'm not sure how exactly it affects everything, but clearly that's wrong. That's quite a substantial difference. I think this divider is a part of this resistor divider right here. Okay, so depending on those switches, it will be adjusting this voltage which drives this transistor. Okay, and it's gonna continue driving the rest of the circuit down here. Okay, so we have to make sure that base of this transistor have exactly 1.1 volt as it is supposed to be. So we're gonna check this this is crazy, this is just resistors, but again, I'm gonna check these two resistors, then I'm gonna go and make sure those switches are properly operational and they are properly dividing the voltage, whatever it's supposed to be. Okay, so these resistors are fine, switches are fine, these resistors are fine. And then I'm probably gonna lift this, like if nothing gonna help, I'm gonna lift this lag of this transistor and measure without this all engaged. Right. Okay, so let me continue. So let me go show the schematic. So I'm in the ohms mode. It's supposed to be 100 kilo ohm, not whatever it's showing here. Okay, how about R, which is, I think it's in the bottom here, R522, 2 kilo ohm. It's supposed to be 47. Obviously they are in part of the circuit, but honestly I do not like that 100 kilo ohm thing, which is not showing anything. So let me desolder that one. That's kind of suspicious that it's not showing any resistance. Okay, so this is a result of my investigation about these resistors. So I did it off camera because it was a lot of poking around and very hard to actually desolder these guys. And notice obviously that these guys are not supposed to be here, they're supposed to be on the other side. So what I have found, so there is a difference between schematic and real life. So in real life, this 3 kilo ohm resistor looks like 4 chrom bias level, is 39 kilo ohm. And in real life, this resistor for metal, this one, is going to be switched away. Like the combination of switches will do that. This 6.8 kilo ohm resistor supposedly supposed to working, but it is actually 3.3 kilo ohm resistor. So my idea is to desolder those resistors. I already desoldered them. Okay, 1, 2. So this one is 33 kilo ohm. This R232. Right here, R232, it is 39 kilo ohm, but supposed to be 33. And R233 is 3.3. So I think I'm gonna just plop here, or here, I'll figure this out. But I think here, because Chrome and the normal is actually more or less levels are okay, but when you switch to metal, it goes crazy. So I'm gonna put here potentiometer, and I'm gonna tweak the resistance to the point I get the correct voltage right here on this transistor, and I hope everything gonna gonna work properly. So let me do that. So I just unsoldered these resistors, put them here for ease of testing. I unsoldered them because I was thinking they are bad, but I unsoldered them. I'll show you from such a crazy location that I don't think I won't be able to solder them back in. So if you think they were right freaking here, so in order to put them back on, I have to remove this. It was easy to desolder them, and then they just fallen out. But now when I have to put them back, it will be much harder. So I just decided to solder them on the other side of the board. It's like not that of a big deal. There's plenty of space here. All right, clearance is perfect, so it's not a problem at all. So what you're gonna do, you're gonna plop here potentiometer. Okay, so here is my potentiometer with wires. I already pre-soldered them, and I'm gonna remove this resistor. This is metal resistor, which is responsible for metal biasing. And we're gonna solder this guy instead. Temporarily, obviously. Okay, so we have this guy in here. So now we will have to power up the cassette deck, and obviously not gonna keep this thing right here, right? I'm gonna turn it around. Okay, I don't know what's the good spot for this, but little tiny, not tiny. So by the way, this potentiometer is a precision potentiometer, and it's 100 kilo ohm, forgot to mention. So that gives me a chance to fine tune the voltage. Gonna keep it right here. See, I'm gonna right on the side of the screen. You're gonna see it. Also, I need to put my multimeter right in here. Power up the thingy, and found the ground point. So I decided to use this instead. So I think this is gonna be good. Grounding point right here. And we'll switch to RMS, and let's see. Hello? What do we have? We have nothing on this side. We have 23 volt in metal, and it's dropping, of course. You see, I'm tweaking the potentiometer, it's changing. Oops, you don't see that. Oh, I'm sorry, I'm gonna make it a little bit wide angle. You see? Okay. Clearly does something. So let me measure something else. I need to measure, not this. Let me measure, so base of this transistor, base of Q7 is the voltage I'm looking for. Okay, I finally found good grounding point. Turned out to be this. Front of the chassis is not grounded, so I need to look into it as well. So anyways, so here I'm measuring 1.3 volt essentially. Let me make it 1.1. And what we're gonna see here. Okay, let's switch back to AC and measure here. 22 volts and dropping. So nevertheless, let me see what's gonna happen on different modes. That's bizarre. Why it's growing in one way and dropping in another? I cannot understand. Please let me check the transistor. Whoa! Did you see that? What the? Did you see what's happening? I'm touching this transistor and the voltage is actually going up. So essentially, it all depends on temperature equilibrium inside this. Holy, like, what's going on here? Well, and here's my idea. So I MacGyvered the makeshift heatsink, right? And for a TO92 package, because it's not easy. And what I've done, look what I'm doing. Okay, let me make it a little bit more snag. Okay, this is my idea. So essentially, this transistor now has obviously a little bit of heat sinking going on. It's a little bit because the contact here is shit, right? You need like thermal compound and something like that, but still, the thermal transfer. Okay, let me see what's gonna happen now. Yeah, it's still dropping. Well, obviously it is dropping, but my hope it's gonna eventually stop dropping. It needs to slow down. Okay, let it sit like this and see if it's gonna slow down or not. I think it's already kind of slower. It's still going down, but looks like it started kind of stabilizing. You see the voltage is actually slowed down. The drop is definitely much slower, and it also sometimes jumps back up in voltage. So eventually it's gonna kind of. Oh yeah, it's warm. The heatsink is warm, but it's warm, not hot, right? Do you want to see something funky? Look at this. You see, I was just blowing on the heatsink and temperature is going up. This is ridiculous. Sorry, not temperature, the bias voltage and obviously corresponding bias current. Okay, I have an idea. What if I replace this with something different? Okay, take a look at this beast. So I found the old and broken power supply and pull out the this compatible heatsink. It's barely fit around the components. It's kind of massive, but nevertheless it has the good contact. Maybe even add some. I didn't add some thermal compound because I don't have any open tube at the moment. But here we are. So I've added this heatsink. I don't really believe this is 100% proper solution because I couldn't believe that the oscillator on its own is so unstable. But let's see where are we? So we're gonna put this here. Gonna find a good grounding point right here, and let's record. So this is normal, and normal is pretty much all the time the same level. Okay, this is Chrome. It's, oops, okay, more or less stable. This is normal, showing you again. And this is metal. This is dropping, wow. I'm just curious at what time, at moment. I'm gonna just leave it like it is and see when it's gonna stabilize. Alright, so after several different tries, I've managed to get it at this level, more or less stable. It's hovering around 26 volts. And I think this is fairly decent, and I'm gonna probably stick to this because I have I've checked out every single component right in here, okay? I've checked these transistors, I've checked pretty much everything here, including this transistor, those two, well, except this capacitor, this and that is checked, this transistor checked, this transistor checked, so I'm not really sure what the hell is going on here. Okay, so yeah, the voltages are off a little bit, but yeah. So if you measure some DC voltages again, like for example at the base of this, it's this guy, base. What do we have? 11. It's 11 volt. Oh, now it's 11 volt instead of 11.4. It's just like hilarious. Okay, and the meter is 10.4 instead of 10.7. It's sort of holding for a while now. That's okay, I'm gonna leave it at that level. So this potentiometer, I'm gonna measure the resistance right here. I'm gonna solder that resistor in there. So this heatsink gonna stay. The main thing to check, which I didn't, is if it's actually this thing is erasing. This is all be hilarious if this thing does not erase. So I already 25 times run through this poor Fuji cassette. It was demagnetized millions of times on high bias. Yeah, so let me see if there is any kind of music on this cassette, or is it empty, I don't know. Yep, there is something. Let me hear it. I don't think that's my recording, somebody else's. Oh, clearly something there. And let's do some erasing. At the level of metal bias. Okay, I just stopped it, and now rewind. Okay, we need to probably go a little bit forward. Yeah, it did erase. Nice. Alright, so erase head working. Our bias is at 26 volt. That's needed to be also tweaked with the actually metal cassette. So now this is over. I think I did figure out what the hell is going on with. No, I did not. I actually rectified the problem. I couldn't still figure out why it drifts, and why it drifts at this current. Yeah, I do not understand. So, but we're gonna leave it at it. I don't think I'm gonna spend too much time on this cassette deck. If you have any idea, guys, what is the problem, please. There is a website down here in the description. You're gonna comment on it and maybe have an idea, or actually comment here in this video. But on the website you're gonna see the schematic, right? And maybe you can play with it, because this is crazy. I couldn't really figure out what's the problem. All these checks up. Right now voltages are more or less okay. As you see, voltage is correct here. I didn't check the voltage here. Actually, I could. But voltage is correct right here. Let me actually do that. So you're gonna check voltages on this transistor. So base, let me just do DC, unless this is bad contact. Okay, 11 point, yeah, that's pretty much, yeah, so this is correct. Okay, right here, base. Okay, the base 1.2 should be 1 volt. Okay, collector 10.6 precisely, and the meter 0.64 should be 0.65. Like, voltages are really nice here. So I don't know what else to say. At least it totally corresponds to the manual. So I double check. So these resistors, this I'm gonna keep. So I'm gonna keep that resistor unless it's gonna be not sufficient to properly calibrate type 2. This resistor is gonna be replaced with something which is, I will read from this potentiometer. Everything else is the same except what I've done. I replaced this tranny with much beefier one with the heatsink. That's it. Every other components, including this suspicious orange capacitor, checks out. I mean, I replaced it with, where's this guy? Another film capacitor. I did replace it with that film capacitor. It didn't change anything. So it's clearly not their problem. Check heads. Heads are alright. Capacitors are alright. This capacitor alright. The resistor okay. These resistors are okay. Yeah, I don't know what else could be a problem here. Okay, so if you have an idea, please help me because I'm stuck. Otherwise, I'm gonna leave it like it is, and that's it. So guys, I think that was long for me because I'm gonna edit it out and gonna be much shorter troubleshooting video where I try to figure out what the heck is going on with bias of this Hitachi D-E7, because it drifts at the metal position. It's not as drifty at type 2 and type 1 positions. So yeah, this is the problem. Anyways, feel free to pitch in, but it'll be continuation of this video where I continue to this is going to be sort of segue when I try to fix this problem. Then it's going to be video where I continue fixing and calibrating this cassette deck. So guys, thank you for watching. Please stay tuned for more video. Stay safe and ciao.